All right, so guys, for part one of our circular motion worksheet, we have all the equations that we're going to need here, okay, and a couple little pieces of information to help us out. So if you have to take something in RPM and put it into hertz, you divide it by 60. Frequency, lowercase f, okay, would equal the number of cycles per second, number of laps, number of complete revolutions or rotations per second. Period would be the time it takes to just make one complete cycle, one lap, one circle, one rotation, one revolution, etc. Okay, period, that is measured in seconds. That is not good. So period is measured in seconds. Frequency in hertz, radius is in meters. If you have to put something in centimeters from something, put something that is in centimeters into meters, you're going to divide out by 100. Centripetal force is in newtons. Centripetal acceleration is in meters per second squared. Velocity, speed, meters per second. All right. So if a race car makes one lap around a track that has a radius of 50 meters in 9 seconds, what is the average velocity? So velocity, we're pretty much looking at one of these two equations. All right. But right now, like, I feel like I'm only given one thing. I feel like I only have that the radius is 50. So what the hell is this 9 seconds then? Since it's making only one lap around in that period of time, that is the period. All right, that's the time it takes to make one complete cycle. So that is why capital T here is going to be this 9 seconds. Okay, so now we look at the velocity equations here. Which one has R and T in it? We have pretty much three, actually, here. This guy. This guy has the R and T. This 2 is just in the equation itself. And pi is a just itself, pi. So you have V is equal to 2 pi R over T. So you're going to put everybody in. So you're going to do 2 pi times R, which is 50, divided by the period there of 9 seconds. Can you guys see? Everybody can see this well? Yes? All right. So in a calculator, you're going to multiply everybody out on top, equals, divide by the bottom, 9, and you're going to get an answer here of 34.9 meters per second. All right. Well, what is the centripetal acceleration? Centripetal acceleration is this right here, centripetal acceleration. And our equation for that is v squared divided by r. All right, well, we definitely have r still, which was 50, and we just solved for v. So we have to use this 34.9 as our value here for that velocity component. So you have 34.9, and remember, you have to have that squared. So in your calculator, 34.9, square that, then divide by 50, and you're going to get 24.36. Now, crap, I forgot. What is my unit here for centripetal acceleration? Well, on the top, I kind of wrote down, guys, a bunch of pieces of information. So centripetal acceleration, it has a unit of meters per second squared. Okay, so then we have Normie Neutron. That's Jimmy's brother here. And they swing a rubber ball attached to a string over his head in a horizontal circular path. The piece of string is 1.5 meters long, and the ball makes 120 complete turns each minute. All right, so we got a couple things going on here. They want to know what the average velocity of the ball is. Okay, well, let's figure out, do we have what pieces of information? The fact that the string is 1.5 meters long, that is going to be its radius here. So we do have a radius of 1.5 meters. And now it tells us that the ball makes 120 complete turns each minute. Now, frequency is the number of cycles per second. But they gave us 120 complete turns per minute, which is a frequency. And that was 120 RPMs. But we don't want RPMs. So if you have something in rotations or revolutions per minute, to get it into hertz, we have to divide it by 60. So we have a frequency then of 2 hertz. All right. So what is the velocity, or average speed, or average velocity of the ball? Well, you're looking at velocity equations up here. Okay, this one needs r and period. This one has r and frequency. Yep, since we do have the radius and frequency, that is going to be the one that you're going to want to use. So your velocity here is going to equal 2 pi r times f, 2 pi times 1.5 times f, which was 2. And you're looking at roughly 18.85, and the unit for velocity or speed here is meters per second. What is the centripetal acceleration? Again, that equation is v squared divided by r. We just solved for v. So we're taking this 18.85, squaring that, and dividing it by our radius of 1.5. Okay, put this into our calculator, and you're going to come out with an answer of 236.88 meters per second squared. Number 3, car goes around a curve at 20 meters per second. If the radius of the curve is 50 meters, what is the centripetal acceleration of the car? Okay, so meters per second is telling us our speed or tangential speed or linear velocity, linear speed, whatever. They're all the same thing. So we have a velocity here of 20 meters per second and a radius of 50 meters. They wanted centripetal acceleration. That equation, just like we've done in a couple of problems here, is just very simply v squared divided by r. All right, so Doc Brown holds on to the, I'm going to let you guys complete number 3 on your own. Very, very simple. The next one. Okay, so he holds on to the end of the minute hand clock atop City Hall. If the minute hand is 4 meters long, what is his centripetal acceleration? So the period would be the amount of seconds it would take the minute hand to make one complete revolution. All right, so let's see. The minute hand takes a little bit of time, right, to make his way around. So in 60 minutes, there are 60 seconds per minute. Multiply these out. So it's going to take a period, right, of 3,600 seconds for this minute hand of a clock to go all the way around. Because it takes 60 minutes to make it go around one time. All right, so 3,600 seconds is the period that we're looking to use. And we are given a radius of 4 meters. So we have 4 meters, we have period of 3,600 seconds. They want to know the centripetal acceleration. So that equation is v squared over r. We have r, but we don't have v. So we can find v by doing 2 pi r over the period. Okay, it's going to be a pretty small number. It's going to be 0.007 meters per second. So once you have v, you can solve for the acceleration. Divided by r, which was 4. And it's going to be 0.1234012 meters per second squared. The next set, guys, of problems that we do, all right, are probably going to be a little bit easier to decipher. All right, there's a couple extra steps in here. Some of the problems that I would like to give, I'm going to break it down first. I'll be like, okay, I may not have you do the conversions like this, converting something into, all right, the full seconds or going from RPMs into hertz, but I'll say, okay, you have these two things, solve for this. Once you solve for this, all right, this would be like 4a, solve for the velocity. 4b, solve for the acceleration. Instead of just saying solve for the acceleration, and then you're like, well, crap, I don't have all of this stuff. I'm telling you, solve for the velocity first, because you're going to need that to solve for part B. So it's a little bit more guided in that sense. Okay, so our last problem that we're going to do today here, you get a flea getting thrills by riding on the outer edge of a oldies record album that has a radius of 15 centimeters and is being played with a rotational period of 1.8 seconds. So for this, what we're going to do is want to find the average speed, right? So that is our velocity. We have two equations or three equations that we can use. They told us that we have a period of 1.8 seconds. So I'm going to use that equation up top. V is going to equal 2 pi r over t. Period was this 1.8 seconds. But radius here is in centimeters. We need it to be into meters. So divide that by 100, and you're going to get 0.15 meters as my radius. Plug in your numbers. 2 pi times r of 0.15 divided by the period of 1.8. You're going to get a velocity of 0.52 meters per second. Oh, sweet, just like I was talking about. All right, so you have now figured out what the velocity is. Now you can determine what the acceleration is. That equation is v squared over r. You just solve for velocity. So you're going to do 0.52. That is going to be squared divided by the radius here in meters of 0.15. Not 15, but 0.15. Huh. Interesting. Comes out to be 1.8 meters per second squared. Roughly, like it's 1.80266 repeating, but just cutting it off there. All right, and that is going to be where we leave off today. All right, we'll pick back up tomorrow, solving for centripetal acceleration, velocity, centripetal force, and a couple other guys. All right, so that's where we're going to wind up ending up today.